Hi folks. In the last video on circles, we learned how to graph a circle using its center and radius. We also saw the equation of a circle with a given center hk and given radius r. What happens if we're given an equation of a circle though and it's not written in that center radius form? How can we manipulate it so that we are able to then find its center and its radius? Well, that's what this video is all about here right now. So if we're given an equation that is not written in center radius form, how can we work our magical powers of algebra to manipulate it so that we can find the center and radius? All right, I'm going to show you some steps as to how to do this, and I am going to warn you that in the beginning the steps are going to seem kind of long. But like with anything else that we do in math, the more we do, the more we practice, the better and the faster we will get. All right, so without further ado, let's jump in. Anytime I want to complete this process, which is called completing the square, what I'm going to do is I'm going to start by grouping terms that have an x in them together, terms that have a y in them together, and anybody that doesn't have either an x or a y, I'm going to add or subtract from both sides of the equation to kind of move it over to the other side. So with that thought in mind for number one, I'm going to go ahead and I'm going to start by grouping my terms that have x's together. So x squared minus 10x. I'm going to group my terms that have y's together. So plus y squared minus 2y. And I'm going to subtract 10 from both sides to move that term with neither an x nor a y over to the right side all by himself. The second step of this process is to actually do what's called completing the square. You saw this last year in your algebra class for parabolas. Now we're going to do it in geometry for circles. What's different this year is we're actually going to complete the square twice. We're going to complete the square first for the x terms, and then we're going to complete the square a second time for the y terms. So I'm going to keep my x's together, but I'm going to leave myself a little room here to complete the square. I'm going to put plus a blank for whatever value I pick or choose to complete the square for the x terms. I'm going to take my y terms and again leave myself a blank for whatever value I use to complete the terms or complete the square for the y terms. And then remember that whatever value I add to the left side to complete the square for the x's, I also have to add to the right side. And likewise, whatever value I use to complete the square for the y terms, I need to add to the right side. And at this point now, I'm going to go in and I'm actually going to complete the square. And in order to complete the square, I'm going to look at the coefficient in front of the x term. In this case, it's a negative 10. I'm going to take half of that value, square it, and add it to both sides. So when I take half of negative 10, I get negative 5. When I square negative 5, I get positive 25. And that's the number that I'm going to add to both sides. I'm going to now go do this same exact process for the y values. So half of negative 2 is negative 1. I square negative 1 and get positive 1. And I add that value to both sides. All right, at this stage of the game, I'm actually going to do a couple things. I'm going to go ahead and I'm going to factor the left side. Sorry, I'm going to factor the first three terms. And by design, this will always factor into a pair of binomials that are exactly the same. So x minus 5 times x minus 5. I'm going to factor the y grouping, and that'll factor into y minus 1 times y minus 1. And I'm going to combine all those terms on the right-hand side to get 16. My last step in the process is I'm going to rewrite the x minus 5 times x minus 5 as x minus 5 quantity squared. You probably have guessed by now that I'm going to rewrite the y minus 1 times y minus 1 as y minus 1 quantity squared. And I'm going to keep that equals 16 and equals 16. But what I have now done is I have now transformed that equation into center radius form. And I can tell by looking at it that that equation, or sorry, that circle, has a center located at the point 5, 1, and has a radius whose length is 4. And if you're having a hard time figuring out how I use that equation to find the center and radius, you want to go back and watch the previous video. Ooh, that was fun. I kind of like doing this algebra together with the equation of a circle from the previous unit. All right, let's keep the good times rolling here. Number 2 says x squared plus y squared minus 4x plus 6y plus 4. Again, I'm going to keep in mind how I want to group these. I want to put all my x terms together, put all my y terms together, put anybody that doesn't have either an x or a y all by themselves on the right-hand side. When I group my x terms together, I'm going to be a little efficient in this problem because I know that that whole notion of completing the square is coming. So I'm going to leave myself a little space to do that. Same thing for when I group the y terms together. I know that completing the square step is coming. So I'm just going to leave myself a little room on the paper in which to do that. And when I subtract the constant 4 from both sides, it's going to leave me with a negative 4 on the right-hand side, plus those two values that I used to complete the square for the x terms, and complete the square for the y terms. Now I'm going to go complete the square. Half of negative 4 is negative 2. When I square that, I get positive 4, and I add that to both sides. Half of positive 6 is positive 3. Squaring that gives me 9, which I then add to both sides. And I'm going to be a little efficient here too when I factor. I know that each of these groupings is going to factor into something that's a perfect square. I know this because that's the way I designed it when I completed the square. So x squared minus 4x plus 4 will actually factor into x minus 2 times x minus 2. But a shorter, more efficient way to write that is to write x minus 2 quantity squared. The second grouping here will factor into y plus 3 times y plus 3, which again, being a little efficient here, leaves me with y plus 3 quantity squared, equals, combining the terms on the right-hand side, leaves me with 9. So now I have very nicely and efficiently put this into center radius form. I can tell very easily from this equation now that this is a circle whose center has coordinates 2, negative 3, and whose radius has length 3. I kind of hope, or I kind of like, uh, doing the algebra here. This is kind of fun. Number 3 is a little bit tricky because we have x terms and y terms on the left side and right side. We've got stuff going on all over the place. So the first thing that I need to do before I can get down to the business of completing the square for this question is I have to move everybody with an x term or a y term to the left side of my equation, everybody without one to the right side. I'm going to go ahead and rely on a little bit of mental math to do this. I'm going to add x squared to both sides. The y squared is fine where it is, but I'm also going to add 10y to both sides, and I'm mentally going to subtract that 160 from both sides. All right, once I put everybody with an x and a y on the left side, now I'm going to get set up to go ahead and complete that square. And now I'm perfectly positioned to go ahead and complete my square. Half of 24 is 12, Squaring it tells me I need to add 144 to both sides to complete the square for the x's. Half of 10 is 5. Squaring that tells me I have to add 25 to both sides to complete the square for the y's. All right, next stage of the game, I'm going to go do my factoring. So x squared plus 24x plus 144 will factor into x plus 12 times x plus 12, which is really just x plus 12 quantity squared. The y squared plus the 10y plus the 25 will factor into y plus 5 times y plus 5, or in other words, y plus 5 squared. The terms on the right-hand side of the equation are going to combine together. Oh, when I get my calculator out and I do some number crunching here, I find that those will combine to make a 9. And all of a sudden, I have now made sense out of chaos. I can now tell very clearly from looking at the problem that this equation or this circle has a center located at the point -12, -5, and whose radius length is 3. All right, folks. So there's what I have for you as far as completing the square to find the center and radius. You know as well as I do that you have some questions to answer about this. Go take off with those, have fun. Like always, if you have questions or concerns or I said anything that's way out there and doesn't make sense, I definitely want you to shoot me an email about that, or at the very least, make yourself a note so you can ask me a question about it the next time we see each other face to face. As always, thank you for the gift of your time. Can't wait till I see you again in person.